Good day everyone, I'm Ayumi Melchor from BSIT 3rd year 5. I will now present my practical exam in Python programming entitled Comprehensive Hospital Admission and Billing System. This program simulates how a hospital collects patient information, evaluates vital signs, computes billing, applies discounts, and assesses the patient's final medical status. The goal is to show how Python can be used to automate processes that are commonly done in hospital billing and admission departments. For the overview and the system flow of the program is very similar to real hospital procedures. It starts with data collection, followed by medical assessment, financial computations, and ends with a well-formatted summary report. The whole logic can be divided into, for the number 1, patient information input, second, vital signs input, third, room rate decision process, fourth, calculation of hospital charges, fifth, discount application, sixth, health status evaluation, and for the last, final output, printing, and summary. For the patient information part, which is the first part of the program, it gathers information from the user using Python's input function. The required details include patient ID, patient name, age, room type, number of days admitted, number of lab tests, medicine fee, and whether the patient needs an operation. Certain values are converted using int and float to make sure they can be used in computations. Examples: age, days of stay, and lab tests must be integers. Medicine fee must be a float because money involves decimals. And operation needed is stored as a string because the value is either yes or no. Collecting information accurately is extremely important because every section of the program depends on the correctness of these values. And for the second part is the vitals. After capturing personal details, the second part collects the patient vital signs, which include temperature, systolic blood pressure, diastolic blood pressure, and heart rate. Temperature is stored as a float, while the rest are integer or int. These values will later be evaluated using conditional statements to determine whether the readings are normal, low, or high. And for the third one, which is room rates, it determines the total room cost using an if-elif decision. Structure based on the selected room type. The available options include ward for 500 pesos per day, semi-private, which is 1,000 per day, private for 2,000 pesos per day, and ICU for 5,000 pesos per day. Once the correct room rate is selected, it is multiplied by the numbers of days of stay using room bill is equal to room rate multiplied by days of stay. This method follows actual hospital billing practices where room fees are based on duration and room classification. And for the fourth part is wherein additional charges computation. The system then calculates other possible hospital expenses, which is laboratory charge. Each lab test costs 1,000 pesos each. So the formula is lab bill is equal to lab test multiplied by 1,000. For the medicine fee, this value is taken directly from user input as a flow. And operation fee, if operation is needed, the system adds a fixed fee of 15,000 pesos, otherwise it remains zero. This is handled using a conditional assignment. Operation bill is equals to 15,000 if operation needed is equal to yes, else zero. After these three values are calculated, they are added together along with the room bill to compute the subtotal, which is subtotal equals to room bill plus lab bill plus medicine bill plus operation bill. And for the discount application logic, the program then determines which discount should be applied using an if-else chain. The criteria include condition, age. If age is greater than 60, the discount will be 20%. If the subtotal is greater than 100,000 pesos, the discount will be 15%. If the subtotal is greater than 50,000 pesos, the discount will be 10%. Otherwise, no discount. Once the discount rate is chosen, the program computes the discount amount and subtracts it from the subtotal, which is the formula discount amount is equal to subtotal multiplied by discount rate, and the total bill is equal to subtotal minus discount amount. This section demonstrates financial decision calculation similar to senior citizen benefits and hospital billing rules. And for the patient vital signs evaluation, the system then evaluates the vital signs using conditional statements to assess whether each value falls under normal, low, or high condition. For the temperature condition, 38 Celsius or above is called fever, and below 38 Celsius will be normal. And blood pressure condition, using logical operators, systolic is greater than 140 or diastolic greater than 90 will be high blood pressure. When systolic is less than 90 or diastolic less than 60 will be called as low blood pressure. Otherwise, it is normal. And for the heart rate condition, below 60 will be bradycardia, and above 100 tachycardia, and 60 to 100 will be the normal heart rate. This part shows how health monitoring system classify patient condition automatically based on clinical threshold values. And for the final report formatting, the program prints a structured hospital summary which includes patient details, vitals interpretation, billing breakdown, discount details, and final total charge. The output is formatted to look like an official hospital admission and billing document with separators, section, headers, and peso formatting with 2 decimal places. This improves clarity and professionalism, similar to printed hospital invoices and discharge summaries. In conclusion, the program successfully simulates the core workflow of hospital admission and billing. It demonstrates data collection, decision-making using conditionals, processing of financial calculations, application of discount rules, evaluation of patient vitals, and presenting a clear final report. And that's all. Thank you for listening.